dort çok bırakat, kan?
Hello everyone. You may wonder what Red Hat, Microsoft, and testing have in common. And I'm here today to answer this question. My name is Todorov, and I obviously work for the company with these cool fedoras. Let me start by explaining the Microsoft part of this presentation first. So I'll be talking about pairwise testing. It's not going to be very technical, so we won't have any problems understanding. Imagine that our job is to test this beautiful car, and immediately you can notice we have a few options for batteries, an engine, and a couple of options for wheels. So we make a list of these to help with testing. For the sake of this example, I have added some older battery options, which we don't see on the website, just to make things a little bit more interesting. And I have also split the engine options dual or single, regardless of the battery configuration. And I have also split performance mode yes or no, regardless of the engine configuration. So all of these parameters, they have 32 different combinations between them. And if we want to do exhaustive testing, that means we need to test in 32 different environments. Or that means we need 32 different cars to do our testing. And that's quite a lot. And imagine if you want to test every single thing in this car, these are more options, more parameters, and the testing matrix grows very large. Pairwise testing is a technique which is based on the practical observation that most faults and most defects are triggered by input of at most 2 parameters. So that's what Microsoft claims and what other people also claim. So we need only 2 parameters to trigger a defect in a very complex piece of software. So therefore, a pairwise testing matrix contains all combination of 2 or all pairs of 2, but it doesn't. It's smaller than the full combination matrix, and the largest size of a pairwise matrix is determined by the 2 parameters with the largest number of possible values. So in this example, we have battery with 4 possible values, and we have engine with 2 possible values. So the product of these 2 is 8, which is the largest size of the pairwise matrix. And if you look carefully in this example, you will notice that there are all combination of 2 present in this matrix. Pairwise test matrices are obviously a lot smaller, but people claim that they are still very effective at finding defects, and I wanted to figure out whether this is true or not. Pairwise testing can also be used as a combinatorial technique to generate what test cases you need to do for every single build. So if you know how to apply the algorithm, then you can create a small program, and for every product version, for every product build that you want to test, you can have a little bit different testing matrix that you want to execute. Microsoft is also behind the community website Pairwise.org, which it has a huge collection of white papers and papers on the topic, and these range from even from the 70s until now. And there's also a huge collection of tools for different languages which can do pairwise testing. So I invite you to check them out. With that said, I finished with the Microsoft part of this talk. What I have done during the last year is I applied this technique with some modifications to the testing of Red Hat Enterprise Linux version 6.9. I did this during the entire testing campaign of the product, which lasted several months. And I did this across all product variants. And I want to share the results of this experiment with you. What my team does at Red Hat is called installation testing. Broadly speaking, we test everything from the boot of installation media and installation of the operating system itself until the time you can restart into a possibly working Linux environment and do something else with it. The primary object of our testing is the installation program called Anaconda. It is written in Python, and this program has several different user interfaces. It has graphical user interface, it has text mode user interface, it even has non-interactive command line interface. And the interesting part of Anaconda is that it actually needs a Linux operating system underneath to actually work. So we need a Linux kernel with drivers to be able to discover hardware and bring up the hardware that we want to use during the installation. We need different tooling, which is available for Linux to do stuff like managing temporal connections or disk partitioning. This picture, for example, is the disk partitioning screen. There are several different types of disk partitioning schemes that you can use, and for every one of them, there are different file system types which you can use. And the fun part is that all these can stack on top of one another, and you can do whatever you like with them. The tools that sit behind this, the installation program only provides the user interface, but the tooling that actually does the job, these are different tools, and we test them indirectly as well. We have 9 different product variants for version 6.9. We have things like client, server, and workstation, and we support 4 different processor architectures. For version 6, we have Intel 32 and 64-bit, and we also have IBM PowerPC and IBM mainframe as architectures, which are both 64-bit. On other versions, and also upstream in Todorov, we support even more types of hardware combinations. So this only makes our products that we need to test very much. Despite all these differences, however, I consider the product to be platform independent for most technical purposes. So what that means is when we compile the software which goes into the installation environment, it comes from the same code base. That code base is platform independent. In very, very rare cases, and very few places in the source code, there is something that checks whether or not we are on mainframe or whether or not we are on Intel architecture. And most of the times we only check the CPU architectures. I don't remember, I've been testing installation for the last 10 years, and I don't remember a single time when something was working on client and it wasn't working on server, for example. So we don't care about the actual content variant that the product is working. So that's why I say product variant is platform independent, and this is very important for the experiment. You will see why in a few seconds. So the standard way the team is doing testing is to split the test suite in 3 tiers. So we have tier 1, which is our first line of defense. This is a very small test suite, about 20 test cases. And then we have tier 2 and 3, which we execute combined. And this is over 300 test cases. So we execute these across all 9 variants for every possible build that we have. During our testing campaign, which lasts several months, we average around 6,000 test executions. So that means 6,000 times we boot into the installation media, 6,000 times we perform installation on Linux, and 6,000 times we restart into possibly working computer to see whether or not it's working. So that takes us a lot of time and a lot of effort, and we take installation testing very, very seriously because all of the products of the company, they use the same installation program. So we test the basis, and then we do a lot less testing for the Iraq products. Obviously, doing so much testing is impossible, it's insane, and it's not practical. So we are always looking for ways to reduce the effort that we do, and let's see what we can do about this. By examining the existing test suite very carefully, the first thing I noticed is we actually have some test cases which are platform dependent. A few of them come from IBM PowerPC, and then a lot more of them from mainframe, because mainframe is quite different from the other platforms. So the only thing I can do with these test cases is to take them as they are and transfer them to my new test plans, the thing that I call my experiment, my pairwise test plan, my optimized test plan. So I take everything that's platform dependent and don't touch it. Then I have a large group of test cases which have parameters, and parameters mean pairwise. So for example, I have a test case which is called storage/ISTA. This means perform an installation during the installation part before we discover disk and we do anything on the disk. attach another disk, another block device which is accessible over the network, over the ISTA network, and use that for installing the operating system too. So we don't want to use local disks which are attached physically to the computer. We want to use a block device which is accessible across the network. The ISTA protocol itself has a few types of authentication. The ones we care about are only three. We have no authentication, a simple one-way authentication through the name and password, or two-way authentication between the client and the server machines. And then we have a networking layer on Linux, which is not part of the ISTA protocol. It's not part of the installation program. This is part of the operating system, but the network layer is managing the ISTA connections. So you don't want, for example, your ISTA connection to drop, and you suddenly lose connectivity with your hard drive, and you cannot execute any program which is on this hard drive. For version 6 of Enterprise Linux, we support two different types of networking stack. We support Network Manager, which is the popular and the latest way of doing networking on Linux. And we also support the oldest way, System 5 and scripts. And all these need to be tested, all these need to be working in the same way. So we have a total of 6 different executions to do for one particular test case on only one variant. If we want to apply Pairwise directly, we kind of fail to make any difference because we have only 2 parameters, and the largest size of the Pairwise matrix is determined by the 2 parameters with the largest number of possible values. So no luck. Then I have product variants. And remember, my product variant is platform independent for pretty much any practical purpose. So then I can consider my product variant as parameter, something that affects my testing, and then I can apply Pairwise to that. So what I've done during the entire experiment is consider the product variant as parameter to existing parameters of my tests, and apply Pairwise to that to generate the number or the list of test cases that I will be executing. On this particular example, we can see immediately we have 50% less test cases to execute. So that's kind of promising. And then we have another group of tests which actually don't have any parameters. And that kind of sucks for me because I can't apply Pairwise. But remember, the product variant is platform independent. So instead of executing the same test case 9 different times on the different variants, I said to myself, let me execute this test case only one time on different variant, but I will randomize these variants, so I execute the same case but on a different product variant from build to build. So this is the third part of my algorithm. You see that the algorithm for the experiment is very simple. But in order to figure out if I'm doing a good job or not doing a very good job, I need some acceptance criteria. The first one, obviously, is I need to reduce the number of test cases that are executed against a single version, a single release for the product. Anything under 6,000 for me will be good. But what I was hoping to achieve in the beginning was something drastically different, something like 50% reduction. Something that can make a huge difference in the way the team works. Then the other criteria is I don't want to be missing any bugs. So if I execute my optimized test plan, I want to be kind of certain that I will be finding the same defects compared to if I execute the existing test plan with the full testing matrix. So I want to have some metric, some assurance that Pairwise is indeed effective at finding defects. And the third criteria is I don't want to increase product risk that much. So product risk is not very easy to measure, but for the purpose of my experiment, I have defined product risk as the bugs or the defects that the standard test plan was able to find, and compared to the same ones which I was not able to find. So if I was doing Pairwise, only Pairwise without the standard test plan, then I will miss these problems and they will go into production, and that's bad, and I don't want to do this. Because of these criteria, I have executed my experiment in parallel with the rest of my team. So the rest of my team, I have 10 people. They are testing the product variant with the existing test plan. We have one engineer responsible for only one variant, and they do all the testing for that variant. And in the same time, I have been testing using my experiment. I have been trying to follow the same deadlines, testing on the same product reviews, reporting the bugs in the same bug tracker. But the results that I got, they were not important to the release schedule of the product. So I had this freedom. So I can do whatever I want. I can fail. That will not affect the release of the product. So speaking of results, here they are. The first and kind of quite important is I was able to reduce my test metric by 65%. So I was doing 65% less testing compared to everybody else. This is the only reason that I was able to complete my experiment pretty much on time compared to 9 different other people. So that's quite impressive. And the good part about Pairwise is that you can actually calculate this on paper without doing any testing. You need the number of your test cases and previous executions that you have, and this is something you probably have already. And you also need the number of how many test executions you are planning to do for the next release. So that's also something you probably have, or it's easy to obtain. And then you can apply the algorithm and come out with a number at the end, and then you compare the two numbers. If the two are vastly different, then maybe Pairwise is something to look at, something that may help you reduce your workload. Or on the other hand, if the two numbers are very close to one another, maybe your test suite doesn't have enough parameters. Maybe Pairwise is not a technique you want to invest more time in. And I'm very happy with this metric because I didn't do the calculations beforehand. This is something I realized only at the end, that you can do this. The next metric that I have is execution completion rate. So I had 76% execution completion rate. That means from all of these test executions that I've assigned to myself, I was able to perform and complete 76% of them. This is total throughout the entire testing campaign. The average for my team is about 85%. And that's a historical number aggregated for many, many years. We don't always manage to complete the entire testing for us, and that's okay. I believe the only reason that my number is smaller is that I was working alone. If we had more people working on the Pairwise testing matrix, then I strongly believe we can achieve 85% easily. And we can also beat these 85%, and we can come closer to 100%. So we can say to our managers and to our stakeholders, yes, we planned for that much testing, and we were able to actually execute all of it. And this is good. And here comes the fun part. Bugs. So I have some kind of interesting results. The first result is 30% of all bugs which were reported against the installation components during this testing campaign of the product were found by the Tier 1 test plan. So this means they were found by our first line of defense. And Tier 1 is it's very, very small. It gets executed, it's fully automated, and it's executed against absolutely every build that we get. Daily build, nightly build, weekly snapshots, it doesn't matter. It gets executed automatically. And what this metric means for me is that actually we are doing a very good job. We have a strong first line of defense. This test suite is almost 20 times smaller in size compared to the rest, and it is still able to find 1/3 of the bugs. So it means it's good, it's strong, and we don't have to touch it. The other thing that this metric means for me is I can probably very easily analyze the existing bugs and the existing tests and tweak my Tier 1 test with a little bit so it can become a lot more stronger. I can add probably 2 or 3 more cases to it, and this metric will increase. Probably, I don't know. Then we have another 30% of the bugs which were found by the Pairwise test plan by my experiment. And what that means is these bugs were found by test cases which are available both in my experiment and in the standard test plan what the rest of the team has been doing. So that means I have been doing 65% less work, 65% less testing, but still finding the same 30% of the defects that the rest of the team is doing with a lot more work. Which for me proves that Pairwise is indeed effective at finding defects. If they exist, it's probably very easy to spot the defects even with less amount of testing. And then I have another 30%, which were found by exploratory testing. And when I read through all of the bugs that were recorded, and by reading them, most of them were not found by what you probably think of pure exploratory testing, a person sitting down in front of the computer and trying to do something outrageously crazy that nobody else has done. Most of the times these bugs were found by a test engineer who starts to follow a particular test scenario. They start to follow some steps, but our testing steps allow a great deal of freedom. We allow a great deal of freedom how you set up the existing environment or what you may have on the system before, and sometimes that affects the results of testing. I don't consider this a bad thing, because that helps us find some edge cases. On the other hand, what this metric means for me is that I'm still missing some particular testing scenarios to exercise these particular parts of the installation program that we have problems. I need to sit down and write more detailed steps and tell everybody on the team, okay, we need to execute these detailed steps so that on the next release we can be sure that there's no regression. So we have some stuff that's not covered, and we need to do our job and cover it. And so far so good, I think. I've done pretty good on most of my metrics, and now I want to talk about stuff that I was not able to find. I was not able to find 4 critical bugs, 3 of which were regressions. And all of these 4, they have the ability to block the product release for an indefinite amount of time. They have we can block until we have a resolution, we have a fix, which can take anywhere from 2 days to 2 weeks until it's done properly and tested properly, and we have a new build and so on and so on. And sometimes we can only do documentation and say, okay, it looks scary, but it's not that scary, go on. But the point is, whenever we see these types of things, everybody gets on high alert because something bad may happen. So let's look into more details. The first problem, upon further investigation, appeared to be firmware dependent. So the problem is you try to install on a particular hardware and the installation program crashes. So that's a huge problem, but it only happens on one particular model of hardware and possibly on only one particular version of firmware. So we are not entirely sure. So although critical, we are not going to block the release for that. With respect to whether or not you do pairwise or you do full matrix testing, these types of problems can appear anytime. We have a large pool of systems that we use for testing. They are in the thousands of systems. And we get a system for testing usually randomly. So I may happen to execute only 2 tests and stumble upon a problematic system. And on the other hand, I may execute 10,000 tests and never actually work on that particular system and never know that there's a problem with it. The good thing is, this is not one of the certified hardware platforms that we advertise as certified and fully working. So we're kind of okay with that. And we also do additional testing for certified hardware anyway, which is not part of my experiment. The next problem, and our first regression, is a problem with the mainframe platform. The installation part and the screenshots that I showed you earlier are from the second stage of the installation program. We have a first stage, which we call loader, and this is executed as the first process in Linux in the boot media, in the installation media. The job of loader is to bring up essential hardware, most notably networking and hard drive, because you may want to have other stuff there. You you may want to load additional drivers from your hard drive, and if you don't have hard drive, you can do this. And then the job of loader is to also search for so-called kickstart files, which are configuration files with information how to proceed with the installation further. The problem in this particular case was the loader was not able to find our configuration file via the NFS protocol. NFS is like Windows file share for Linux. It's a network file system. So we failed to do this, and we failed to do this only on IPv6. On IPv4, it was working. And that was also failing only on mainframe, not on the other platforms. So first, the reason for that problem is that was in part of the code which tries to activate network connections, and if we cannot activate the connection for some time, we try to deactivate it, and we try a few times to activate it, and that was failing. The problem appeared to be that IPv6 and IPv4 work a little bit differently, they behave a little bit differently, and nobody, including the developers who wrote that part of the code, they knew there was a difference. So we actually have a hidden dependency on the underlying networking protocol and all the environment, how we set up the environment. So that's something we didn't know, and we need to do testing on both of the protocol versions, not only one of them, whichever happens to be in the lab. The other problem is on mainframe, we actually have a different loader program. We have two loading programs. The first one is specific to mainframe, and that loads the second one. And the problem is in the platform-specific code. So I didn't know about this, and that's mostly due to my inexperience with the platform. I don't have a lot of experience with mainframe as with Intel platforms. And during my experiment, this test case I consider to be one of those which do not have parameters, and I can execute everywhere I like. This doesn't have parameters. It says, install Linux and fetch the kickstart file via NFS, and that's it. There's also a different version of the NFS protocol, so that's also something to be aware of. And that's all these things that I didn't know, that testing was not aware of at large. So there is a risk something bad may happen when we do less testing. Then we have two other regressions, which were both, I missed this simply because human error. That's error on my part. The first one is a very trivial problem, again related to networking. I started testing this. We have an environment which need to prepare for that particular test, and I kind of failed to prepare my environment properly. I decided to go manual prepare the environment because I thought it's going to be easier for me. And I failed to do this, and I said to myself, okay, let me skip this test this time. A big deal. I'm not going to test one test of a couple hundred. I will test this on the next build when we get it probably next week. So I decided to skip this test, just like that, no reason. And as you see, I didn't do my job properly, and that was a problem. And if it was something that goes directly into production, that's bad. And then the second problem is something that I've actually tested very early in the release cycle and didn't test until very late again. Sometimes we get builds very often, very close to one another, and we don't have the time to execute all the tests on every single build. So we have decided if this is the case, or if we are in that period of the release cycle where this problem happen, we start testing on the first build that we get, and then we continue testing on the next build that we get, and then continue with the third and so on until we aggregate all the results from all the possible builds, and we give a statement to the stakeholders whether or not we think everything's okay. And what happened is, because I have less tests to execute, I was very quick to execute most of them on the first build, and everything was working. And then on the second build, there was a change in only one single component of all the components that go into the installation, and that was the regression. And because I've already marked these test cases fast, and said to myself, okay, I'm not going to execute this one more time because I already did it. And obviously that's kind of bad. The thing to be aware of is when we do pairwise testing, or when we do any kind of optimized testing, we don't execute all the tests for every build, and we have to be aware of this. When we decide to skip testing or when we decide to not do something, we need to be aware that there is risk involved. A few lessons that I learned is, first one, I don't need my team, because I was able to do everything alone, so why need 10 more people? And I'm joking, of course, that's not true. I need my team, but I don't need them to be testing the product as they are testing now. I don't need them to spend all their time only on verifying something which can be verified with less testing. If I can reduce testing maybe by 65%, that means I can have only 3 or maybe 4 people, we say, executing the actual tests, and I can have the rest 6 people doing something more fun, like, for example, writing automation all the time, or working on infrastructure and tooling all the time. And that's going to be cool. The point is, you have a huge resource, and how you use that resource is up to you. It depends on your team and what activities you do. But Pairwise can help you get the resource that you've always wanted and never had. Another thing that was revealed to me was when I started doing my experiment, I decided to create a small program to help me create a list of individual test cases that I need to execute for every single build. And to do this, I had to read through the entire test plan and had to describe all the parameters of my test cases. I had to figure out whether or not they are applicable to one architecture or to another. I had test cases which were written, they say, oh, you can execute this on every platform, but in reality, that's not always the case. And by doing this, I found a lot of stuff about my existing test suite. I learned a lot of things. And mind you, the existing test suite is probably 15 years old. It is a very old test suite that we started using when we first got the installation program for Linux. And it's been evolving ever since. The point here is, as a team, we don't do this exercise of reviewing the entire test suite regularly. We do post-mortem meetings, we read through the critical and high important bugs that were reported, and we kind of say, oh, okay, let's see what bugs we have, let's write a few more cases for them. Okay, we have 5 more cases, what should we do with them? Add them to the test plan and we'll execute them whenever we have the time. And I've seen many people and many teams do this simply because they don't have enough time. And now that we have time, it is my opinion we should strongly consider sitting down and reading through the entire test plan, through all the test cases, probably once a month, or maybe 1 or 2 times per release, and figure out how we can improve this, how all the test cases relate to one another, remove some overlaps, probably. Slides now. Okay, so I've also observed a lot of patterns which are related to my particular kind of work. Stuff that I can use to optimize the execution of tests. And I'm not going to bore you with the details. My advice for you will be to, if you do these kinds of experiments, or if you do any kind of experiment with testing, either get into the bad habit of writing down everything that you do and then analyze it, or better yet, have a second person who will be observing what you do and they take notes of everything that you do. And then you sit down together and read through all of your notes and try to find some patterns, something that you do repeatedly. And then if you find patterns, then you can probably optimize or remove them or whatever you like. In my particular case, I can pipeline tests. I can combine several scenarios to execute in the same installation. I can execute some test cases in batches because they kind of depend on one another. Or I can have test cases where the output of the previous test case is very similar to the required setup environment for the next test case. I do have such kind of dependencies between the tests. The good thing about all these things is if we start combining test cases with one another, we can consider this to be yet another parameter, and we can try to apply pairwise on the next level. I have not done this, but it's very tempting. I've talked a lot about the rewards that I think we get from this experiment, and in my opinion, this is a viable strategy for testing. And my team is definitely going to use this. We have the next release coming in a few months, and we are probably going to rely only on pairwise without a safety net. So everybody will be doing pairwise, will be testing following this algorithm. And we think nothing bad is going to happen, at least for one of the products. But still we have a few risks. The biggest one that worries me very much is the risk of missing regressions or very important bugs, stuff that can block the release. And I don't want to be going to a meeting with my stakeholders and telling them, yes, testing is passed 100%, and then on the next day we have something critical going to customers. There are a few ways to mitigate this kind of risk, particularly to my testing activities. One of them is, I mentioned, we don't do all the testing on every single build. Now that we have time and we have resources, we can at least try to do more testing on every possible build. We can try removing this practice of aggregating results and see what happens. On one hand, we reduce our testing matrix. On the other hand, we try to do even more testing, so we have to find the balance. How much is enough? Then we have components. On an average, Linux operating systems, there are about 5,000 to 6,000 different components, which we call packages. These are different software which get compiled and they go into the distribution. About 200 of these somehow related to the installation environment and go into the installation media. We have the information from our build process, which components have been changed. We also have information about which particular bugs have been fixed. Bugs are annotated with that particular tests for that component if they exist. Hopefully they exist. We also have the information from the build process of the installation media. We have the information which components go into that particular version of the installation media. And we also have the ability to mark test cases with component tags. So what we can do is we can establish a baseline using Pairwise or any other method and execute these tests as a baseline. And then we look at the list of components that have been changed and say, okay, let me add a few more cases which are particular to only that component, just only to make sure that nothing bad is going to happen. And this is possible to do. So it sounds like common sense, but when you're testing, common sense is not that common. And the last thing that I kind of don't really like is that we are very dependent on the human factor when we do test execution. So it's okay to have humans do test planning. That's what we humans are very strong at. We do planning, analysis, stuff like that. But when we do executions, I have 10 different people on the team. They have different levels of experience with Linux. They work differently. Somebody may use the mouse mode, somebody may use the keyboard mode. I particularly don't like the graphical user interface mode because I work remotely, usually a very slow network connection. I like the text mode user interface. And installation, text mode versus graphical, although it's similar, it's not the same. So some things are different. And I want to remove this factor where we have different people and they kind of work differently. I want to spend their energy to do something else. And what we can do is we can strive for 100% automation. And now that we see we can have free resources, this is something which we think is achievable. We can try to do. The other thing that we need to do, if you cannot remove humans from testing activities, is to actually we need to be very diligent as test engineers when we do testing. And especially when we skip tests or we don't do something, we need to have some kind of policy. Imagine if you are the developer and want to push a change on GitHub that fails the CI build, then you need somebody else to approve your changes. You can't do this alone. And probably you need 2 or 3 people to approve if something very badly broken. When we do test execution, in my experience, we don't have anybody else to police what we do. So we are given a lot of freedom, and with that, of course, comes responsibility, and we need to police ourselves. We need to establish team policy, which says, if you want to skip testing, if you don't want to do something, there needs to be a very, very good reason for that. So with that, I'd say thank you, and we have 5 minutes for questions. Okay, questions or no questions? Who raised their hand? Oh, okay.
You mentioned something like example tests. We have probably we have a platform which is the recruiter that narrows application factors is never actually.
Okay, so the question is that there is a possibility for such a test to never be executed. So how do we track this?
That is the determination of your test matrix.
Okay, so
always execute the same test.
Okay, this is correct. I don't always execute the same test, and actually I think for every single build, my testing metric has been a little bit different. I do have a test case management system, which I use, and I can, in this system I can track which particular cases have been executed, how much they have been executed, which areas of the installation have been covered more often than others. And yes, you are right. Well, this may be a problem. I have not counted this precisely, but from my memories, I think I have all the test cases executed at least once. So I didn't have a test case that was never executed. So and it's not possible to have never executed with the algorithm that I described. Maybe with some other algorithm there could be possible. Okay. Do you have questions?
Yes.
Okay.
One question on improvements. You explained main improvements already. And my question now is, what's the next one in short term? You have them in your to-do list already.
Okay, so in my short-term to-do list is to actually apply this experiment. So that's been only an experiment so far. I'm going to apply this to the regular job that the team does, and the team is aware of the experimental results, and they feel safe with that, so they are okay to adopt this as our main testing strategy for this product. And then we don't know. We have our testing cycle is very long; it's several months long. We have several months. We have from the last release 6.9, we have almost 1 year lead time until we get the next release. So it's that long. And sometimes we do testing several months, non-stop. So I cannot predict what will happen and how much, for example, other products or other schedules will affect the team. If people will leave the team or they won't leave the team. So we are going to start applying this, and at least for myself, I like to keep notes of everything that we do and revisit my notes from time to time and think about the future. Okay, we've done this, it worked, it didn't work. What we can do next, and that's my plan for the short term. Okay, thank you. Okay, last question.
Okay. What I would just say is to expanding the test suite is losing knowledge in the team. Like, for instance, in terms of Linux information, everything is consecutive, and you lose a developer who can tell you that in the next build, this and this will be affected because he developed that. You lose with that. You lose the knowledge. Now you have to test everything more and more.
Sorry, I don't understand how I'm going to lose knowledge.
Like, no proper transfer to knowledge from a guy who leads the team. Does that extend the test suite?
Okay, so the question is, somebody leaves the team,
yeah, it doesn't
we lose knowledge.
Yeah. You have to test everything more exhaustively.
Well, in this true, you are correct that if somebody leaves the team, they take all the knowledge with them, and if it's not documented, then it's a very bad thing. And this is especially true with people that we call architecture owners, somebody which is expert in, let's say, mainframe. And that's why we try to have more people who have experience with different things. Otherwise, if it's not documented, we lose it anyway. It doesn't matter if I do less testing or more testing. Okay. Thank you very much, and enjoy the rest of the night.